Hello everyone, welcome back to OWASP Mobile Top 10 series, and in this video we're looking into threat number 7, which is insufficient binary protections. This threat is unique because once you release your application, attackers have it forever. Unlike server vulnerabilities, you can patch instantly. Binary protections failures are permanent. So let's explore what this means, how it's exploited, and what you must do to protect yourself. So let's dive in. Insufficient binary protections means releasing applications without defending against reverse engineering and tampering. So when you distribute a mobile application, you're giving attackers unlimited time to analyze your code. And these manifest in 4 critical features, where you absolutely do not do any code obfuscation, and these will expose everything, including method names, class names, API endpoints, business logic, after an attacker decompiles your application package. Competitors instantly understand your innovations, and attackers will extract algorithms that took you months to develop. And next is missing anti-debugging controls. And without these checks, attackers attach debuggers to running applications, watch secrets being generated, and authentication flows executing, as well as security decisions being made in real time. Number 3 is where there is no hooking detection, and frameworks like FreeDelete attackers inject code into running applications. So they'll hook into your license verifications to always return valid, modify authentication to bypass checks, or even intercept encryption keys as they are generated. So your application will continue running unaware it's been compromised. And number 4 is where there is no integrity verification. Attackers extract your APK, modify it, insert backdoors or malicious code, and then repackage it and redistribute as legitimate. So users will believe they're installing your application, but actually getting compromised versions carrying your brand name. And technically, impact-wise, this can lead to secrets being extracted from decompiled binaries, as we've seen many times in our previous videos. And this can lead to leaking of API keys, encryption keys, secrets, authentication tokens, and all these things related to tokens and secrets. Number 2 can also lead to logic bypass, where every security decision in your application becomes a target, where something like license checks gets removed, authentications are bypassed, transactions validation are also modified. And it can also lead to repackaged malware, where your application becomes a vehicle for malware distribution. And in this case, attackers will insert backdoors, data theft code, or add networks. And the compromised versions of your legitimate applications will look as legitimate, and of course users will blame you for security breaches you didn't create. And finally, code reuse in malware, where criminal groups extract your encryption implementations and security logic, and then integrating them into the malware source code. Ironically, this means your security codes ends up protecting the criminal infrastructure. From the business perspective, the impact will entail brand abuse. Of course, thousands of malware-laden clones would exist of your popular application, and users will not understand that there is something to do with repackaging, and the download that will appear to be your application will get infected. And of course, the users will blame your company, and your brand name will become associated with data theft and security breaches. It can also lead to revenue loss, where license checks can be bypassed to enable wide-scale piracy, and premium features unlocked without payment. And these days, games see 40 to 60% piracy rate, and subscription applications will face zero revenue when protections are removed. If your keys have been exposed, have been leaked, and these keys are probably related to back-end integrations, then it can lead to the compromise of those downstream systems. And attackers will, of course, query your databases, modify data, impersonate legitimate clients, and your infrastructure will get compromised using your own legitimate credentials, and this is very hard to detect. Last but not least is intellectual property theft, in that proprietary algorithms will be extracted from your binaries and they'll become public. And of course, competitors will now implement identical features instantly, and all your months and years of research and development will become free leverage for anyone willing to decompile your application. So all these issues, threats, and risks can be mitigated through implementing code obfuscation using tools such as R8 or ProGuard on all your Android release build without any exemption. You do it in layers. This will make your code nearly incomprehensible even when decompiled. On iOS, you can strip symbols and obfuscate strings. You also need to add anti-debugging to detect the debugger attachment and respond to terminating the application or entering restricted mode. And in this case, you need to combine multiple detection methods, because attackers will almost always try to bypass and can bypass individual checks. You also need to detect runtime tampering by implementing periodic checksums of critical functions, where if there is a hooked or modified feature, and then you need to disable that feature or even completely terminate it. And this can be done if you are able to detect these hooking framework artifacts and unauthorized code injection properly. In addition, you should utilize platform APIs like Play Integrity API on Android to verify that your application is legitimate and unmodified. You can get cryptographic attestations to validate server side. And on iOS, you can verify code signing and entitlements. You also need to verify package integrity by storing cryptographic hashes of your original package and periodically verifying that nothing has changed. This can be done by detecting and responding to all these repackaging attempts. You need to secure your keys and secrets. Should never uncode them. Always utilize Android key stores or iOS keychain hardware protected storage that is even inaccessible with root permissions. When it comes to keys management, then you need to provision and derive these keys dynamically where possible. In terms of implementing security critical logic, it's important that you use native code. The programming languages like C and C++ is good in this because they are significantly harder to reverse engineer than the managed code. And you need to add obfuscation for these native implementations. As I said earlier, defense in depth is key. No single protection is sufficient. A layered obfuscation and debugging mechanisms, runtime checks, and platform APIs. You need to make exploitation expensive enough for attackers to leave you alone and target easier victims. So the goal is don't be an easier target. And always know that once your application is distributed, then your binary is permanently out there. Attackers will have unlimited time to analyze it and exploit it. So you must implement proper protections from day one. Use layered defenses and get it right on first release. And you continue, of course, to monitor for any repackaged versions of your applications in the wild. So this is for now. Thank you for watching. See you and you're welcome.